Hi, this is the rehearsal for my presentation at NERA. I will share my screen and begin with this. So, uh, the title of the presentation is um, about the risk of having item pre-exposure on items generated using LLMs. This is a collaboration with Christopher Foster, and we worked together in this idea that actually he had on how how it can happen that if a person uses GPT or any other LLM to create questions, then depending on the way they do it, you can actually have partial or total access to the set of items they created if you do a similar request. So if, for example, you rely on GPT's general knowledge base to create the questions, then those items probably will be more easy to replicate by a second agent that is kind of like even unintentionally can happen actually, that someone can ask for items about the same topic and they can get similar questions. So we wanted to understand this new problem, which is I don't think we have ever had this type of situation in which an item, even at its creation, is already exposed in some way. So we wanted to see like how bad was the problem and what can you do to solve the problem if there is a problem. So, well, in general, item generation using AI, well, in 2024, I guess it was like very hot now. It's okay, but people are moving more to the agentic stuff. But still, I mean, companies are interested because you can reduce a lot of costs. If you use LLMs to create items, you can also make your project much faster because you can save time on some of the tasks, pass that to the AI and have them solved rather quickly. So it is tempting, it is convenient. There are many reasons for why this is happening and actually can be done eventually with enough quality. So, uh, but yeah, we have now this possibility of item pre-exposure. In general, item exposure is something that we know is complicated. That's in Cabin, we usually recommend our clients to have big item pools. You use randomly parallel tests, so you expose them in a way that is more complicated for people to harvest your item pool. And it's a big threat to validity and to fairness. I mean, if your item pool is really exposed and you will see that in your psychometrics, people will start to use the information. Over time, you will see how items are changing their psychometrics like live. People that can pay for those services will have an unfair advantage. So yeah, and it's a big cost to the test industry in general to renew your item pool so quickly. So the cost of creating items is a blocker in that way, in that regard to the protection that you can have against item exposure. So item pre-exposure, as I said, is the specific for the case when you have two agents that are doing a similar request in terms of like item pool generation. So you have agent A that let's say is a teacher or is like a company, a testing company. They request some item from the GPT, eventually including some materials or not, it depends. But then a second agent, they can do a very similar request. And how many of those items are actually shared of two pools that two independent agents generate? Then, well, of course, what solution we can provide to this? So we did two experiments, one that we named baseline and one that we named creative. So for the baseline experiment, we generated item pools of 20 items, multiple choice items for options for each question. We requested to generate items using GPT-4o using the OpenAI API. We every time we request an item, we put a specific label for the difficulty level. So we have requests for very easy, normal, hard, very hard, and insanely hard. We try different temperatures as well, 0.3, 0.7, and 1. Temperature, if you don't know that, it's kind of like a value that quantifies how tolerant is the model to pick a next token that is not necessarily the exact optimal from a maximum likelihood perspective. So temperature 0 means that you always pick the optimal. And the more temperature you give them, you will take set like tokens that are around that optimal, but not exactly. We also cover five subjects: biology, geography, history, literature, and mathematics, generating items across all those subjects. Um, and we repeated the request 10 times for each of the combinations in this design. So after you have two pools, basically we use cosine distance and Bert embeddings to quantify the distance between two stems and check like how similar they are. So distance 0 means they are exactly the same, and the bigger the distance, the further away they are in terms of like what they mean. So then we have like two pools of 20 items, and then we have like a lot of like pair distances. So we calculated like an optimal matching around those two pools. So basically we match this item with the closest you can have and so on, and you do that all together. So that's a usual problem of discrete mathematics actually, of like optimal matching for minimum weight in this case. And having that optimal match, then we consider that two items were paired, two items that were paired in this optimal were pre-exposed if the distance was less than 0.15. So that threshold was very arbitrary. We had a feeling of like why that makes sense. So I here put an example of like two stems that are not exactly the same, but still are under the threshold. So, for example, which of the following structures is primarily responsible of producing ATP in eukaryotic cells? And then if you, I mean, it's very similar. It's like almost a paraphrasing uh, of the of the stem. So maybe it's not exactly the same, but it's similar enough. But still, it is arbitrary. So for the creative, we use something very similar to the baseline, but now in one of the pools, we requested for the agent to add a creative kick. So basically, randomly, we picked some phrases that would help GPT to be more creative in the generation of the question. So these are the list of like kicks that we included. For example, introduce a possible real-world mini scenario that fits to the topic. Frame the STEM in a more engaging narrative. Avoid the most common classroom tropes. Use some creative way of asking the same question, etc. So all of that, we basically took like a random sample from that set, and we put all of those creative tweaks into the prompt. But that's only in one agent, simulating that what would be a scenario of like you testing agent, for example, creating a test using this. So in general, for this study, we see that the baseline case for the lower temperature level can be very high, like 60% of the item can be pre-exposed. And it goes down as you have more temperature. It's kind of expected that we hear in some way. And if you add the creative, in which you add some little asymmetry in what one agent requesting versus the other, actually you can go down a lot to the best, which is like 10% with the higher temperature level. So, and 0.7 is a default. So usually people probably will be here, like 40% item pre-exposure on average. That's also depends on the subject. And you can make it down to 10%, kind of. And also this depends on the threshold. If you want to do more restrictive, maybe that's different. In terms of subject, we saw differences. So some subjects are more prone for item pre-exposure than others. In general, we see that the topics that are more scientific apparently are more protected in some way from this problem. And also the creative kick can can have some proper effect on each subject. An interesting thing we saw is that item difficulty, at least this proxy that we use with GPT, which needs to be studied on further, and there's a different research question, but we'll trust that GPT is doing a good job on putting the difficulty level. It has a lot of relationship on this. So if you create easier items, you will have more pre-exposure. And then the harder your item, also the harder it is to pre-expose. So that I find that interesting in general. And that seems to be like a pattern regardless of baseline or creative. So now if you combine temperature and difficulty level, you will see that, again, you see the same trend that if you have more temperature, you will have less pre-exposure, and also the harder the item, the harder it gets to pre-expose. So you see that, well, it's maybe except for the easy and normal, they kind of like flip, but the pattern is pretty clear. However, in the creative, it is interesting that there is some interaction here because the easier items are not getting that much from the creative kicks as the other ones, which is also kind of like interesting in its own. Also, if you see the subjects, the same pattern again. If you get more temperature, then you will have you will protect your item pool better. And purple is math, blue is biology. The two scientific subjects kind of like always down compared with the others. So conclusions, careful with generating items using generative AI using low temperature that can have a lot of pre-exposure. The more difficult the item, the harder it is to pre-expose. Scientific subjects apparently are less prone to item pre-exposure. Adding creative gifts can actually help to make your item construction more unique and protect yourself from this new threat. Temperature 1 may be preferable to a default from this experiment. But still, I don't think we covered yet how temperature relates with the correctness of the item. So eventually you will need to work a little bit harder, do extra work to get your items correct, because eventually we imagine that if higher temperature also will create more incorrect items, but that's a hypothesis because we don't know. And yeah, next steps, how prevalent is this problem when we use GPT through the web browser, which is probably the more realistic case. What makes a content domain more prone to item pre-exposure? We don't know. And how well GPT interprets the words for difficulty level. That's also an open question that we still don't know fully. That's it. Thank you very much.